Hello everyone, welcome to Penang Home Tuition. Today we are going to talk about the scientific investigation, but more detailed, we are going to talk about the interpretation of graphs of different shapes. So we're going to look at some graphs and we're going to see the shapes and what does the shape means. Now for the first graph, it's this one. The type of graph is a straight line that passes through the origin. The origin itself is here, where the coordinates is 0 and 0. It passes to the origin. Now the interpretation of the graph is y, which is this one, is directly proportional towards the x, which means when the y increase, the x will increase proportionally. Proportionally meaning it will increase in a straight line from the graph. Now we can check the gradient, or in Bahasa Melayu, the cerun of the graph by using the formula, this one. The change in y over x, the change is in x, is equals to the gradient, and the change is y is y2 minus y1 over x2 or minus x1. Now where can we find this number where can we find this number y2 minus y1? Where can we find y2 minus y1? So we just take a point from the graph itself. We take this one to be y2 here, and y1 here, and we also take here as x2, which is this x, this part, and x1, which is this part. So when you find the coordinates, you can just take y2 minus y1 over x2 minus x1, and when y2 minus y1, we actually will get this part, and when x2 minus x1, we will get this part here down here. So basically we are dividing this by this, we are dividing this by this to get the gradient, and the linear equation, or the equation, would be y equal to mx, because this is y, this is x. When you bring the x over here, you get y equal to mx, which is the linear equation per se. Right. The next graph we are going to look at is a straight line graph with a positive gradient that does not pass through the origin, meaning no passing through the origin. It has a intercept at the y here. Now it's the same as the gradient will be the same as the first graph, which is y2 minus y1 over x2 minus x1, but we have an intercept c. There we go, an intercept c there. So again, we get the y2 minus y1 here, which is just y here, and x2 minus x1, which is the change of x here, y here divided this one divided by change of x is equals to the gradient. There we go. And because we have y-intercept, there we go, right there, because we have the y-intercept, it's actually we have to plus by the y-intercept to get y, if we ever have m and x. Why do we don't have here plus x plus c? Because the c itself here is already 0. See, the intercept is intercept at 0. That's why the c is 0. So we don't put c here because it's already 0, but we have to put c here because there is a value. There we go. This is the value c here. There we go, the c value. Now for the third graph is a straight line with a negative gradient. There we go. That does not pass through the origin. Now y decreases linearly with x. Is the same. We take the change of y over the change of x, yeah, equals to the gradient. Then we have the c-intercept, which is this one. Even though it's up here, it's still here. And the linear equation would be y equals to mx plus c, the same as this. However, we have to watch out for the gradient here. The gradient here, the value would be a negative value. It could be -3, it could be -4. Either way, we would have here a negative value, while the m up here would be a positive value. That's the only difference between up here, uh, between the graph going up and the graph going down. Just the value of gradient. This one would be positive value, this one would be in negative value. Now the fourth graph is a curved graph with a positive gradient that passes through the origin. So we just have a curved graph here, and for the curved graph we can't have any the equation is very hard, and we're not going to cover in form 4 yet in this earlier chapter, but we're going. So what we can say is just that y increases with x. Either way, if it's go up here, if it goes like bend like that, or if it goes bend from down to upwards, we could say that y increases with x. And the fifth one, we could say that the it could go down there, and it could bend like here also. We could say that y decreases with x. And this one is a curve with negative gradient, this one is a curve with positive gradient. With this one passes through the origin. If it's touch 0 0, we could say it passed through the origin. If it does not touch 0 0, it does not pass through the origin. It's simple as that. And the last graph is a curve with a negative gradient that does not cut both axes, meaning it does not touch any of the y-axis or the x-axis. The straight line y against y over x with a positive gradient that passes through the origin, meaning it has a inversely proportional towards the x. As the x increases, the y decreases. That's what this is trying to say. The y is inversely proportional towards the x. And if you can see here, why is this having a directly proportional? It's because you can see the unit down here. This is 1 over x. When y is inversely proportional, this is trying to say that as the y increases, the x decreases. But the graph interpretation would be increasing because the graph itself is the unit is 1 over x. So when this one is increasing, this is actually decreasing as it goes further upwards. As it goes further upwards, it's actually decreasing in x, but it's increasing in the value of 1 over x. So that's basically the graph interpretation, and there are many more graph interpretation to look at, but that is the general idea of it, and I hope you get something from it, and thank you very much.